All right, finally we are going over how to write chemical equations. Usually this is going from like a word equation to a chemical equation that actually uses the chemical formulas of those things that are involved in the reaction. So again, chemistry is like cooking. You can't lick the spoon. Sometimes the food fights back. So again, chemical equations are just recipes for chemical reactions. Recipes not only tell you what is in the food, but also how to prepare it and how much of each ingredient, and other details about how to cook the meal. Chemical equations also include additional information that tells scientists this stuff. So we need the same type of information to carry out chemical reactions successfully and safely. Word equations are time consuming to write. They don't show us the chemical formula, and they're not very convenient for things that chemists actually need to do with equations. So a chemical equation, again, is a representation of a reaction that shows reactants and products with chemical formulas. A complete chemical equation includes how many moles of each chemical species is involved in the reaction, but we won't be writing those yet, okay? So later on in chemistry, you would learn how to determine how many moles of each chemical species is involved in the reaction. A skeletal equation, which is what we are going to focus on right now, shows only the formulas of reactants and products with no numbers in front of them to indicate relative amounts. So the skeletal chemical equation for a reaction with methane and oxygen that we talked about in the last set of notes is shown below as CH4, that's the chemical formula for methane, plus O2 yields CO2 plus H2O. So I'm not writing the names of them. I am instead writing the chemical formulas for those species. There are also things that indicate physical states in chemical equations, and these are like less known. Sometimes you see them without their states, but these states of matter really do help chemists understand what's going on and how the reaction is going to proceed. So that's why they're really useful. So it's important to know the physical state, and there are symbols that go in the chemical reaction to tell you those physical states of matter. So we use an S for solid, an L for liquid, a G for gas, and an AQ for aqueous, which means it's dissolved in water or is a water-based solution. So the reaction that we just went over, methane and oxygen both exist as gases. So they would be methane gas and water gas, or O2 gas. And then yields, CO2 typically exists as a gas, and definitely will under this equation, and H2O liquid. Sometimes you'll also see H2O gas, just depending on how much heat this produces is going to determine whether you get liquid water or gaseous water. But that's how we would show the physical states for those reactants and products. These are the symbols that you will see in a chemical reaction. We've already gone over the yield sign, which separates reactants from products. You pretty much know what the plus sign means. It's just used to separate multiple reactants or products, telling us that we are adding those things together or getting both of those things. Some chemical equations, you will see a double arrow, which tells us, basically, we call the reaction going from left to right the forward reaction. Usually, most reactions actually, they have a forward reaction and a reverse reaction. So as you make products, those products can basically come back together to go back to reactants. So that would be the reverse reaction from right to left, okay? So that's what the double arrow means, just means that the reaction goes both ways. S shows a solid, L shows a liquid, G shows a gas, and AQ shows an aqueous solution, which means it's dissolved in water. Sometimes you'll see some sort of formula. This one shows platinum, PT, which is basically saying that you have to add a catalyst to the reaction. And a catalyst basically just makes a reaction more likely to occur, helps the reaction move along. The little triangle, which is really a Greek delta sign over the reaction arrow, indicates that the reaction is being heated. We're adding heat to the reaction. Some reactions you add heat, some reactions release heat. That delta kind of just shows that heat is being changed in the reaction. So we're just focusing on skeletal equations. We're not going to worry about how to determine how many moles, basically the coefficients, the numbers that you see in chemical equations. We're not going to learn that quite yet. If you do AP Chem, we will definitely be learning that. But what does the skeletal equation, what we're doing now, tell you? Why would you want to know the physical state of materials in a chemical reaction? Why do you think that would be helpful to chemists? In a chemical reaction, what does that arrow mean? Okay, and also what do the other symbols mean? But the arrow is the one that you're going to be seeing most often. If you see a triangle or a delta symbol over the arrow, what does that mean? What does that indicate? Okay, so that's our little introduction to how to write chemical equations. Let me know if you have any questions.